Hi, I'm Paul Epps. We're doing Leetcode, must know interview questions. Today's challenge, insert, delete, get random, O1. This is rated as medium difficulty. So what do we have to do? Implement a randomized set class with the following method, the constructor to initialize the object. Insert an integer. Well, now let's say something about sets. A set, either an item is in a set or it's not in a set, but it's not in a set multiple times. So if we do an insert, give it an integer, it'll insert the item into the set if it's not already in the set and return true if the item was not present, otherwise it'll return false. All right, remove. Again, pass an integer as a parameter, remove. It'll remove the item from the set if present and return true, otherwise it returns false. GetRandom returns a random element from the current set of elements. It's guaranteed that at least one element exists when this method is called. Each method must have the same probability of being returned. You must implement the functions of the class such that each function works in average O1 time complexity. They have examples here, or they have an example. The input format is actually, to me, it's kind of hard to understand, but it doesn't really matter because we don't have to process the input. We just have to understand what is required from each method. But to take a quick look at the input randomized set. So if that comes in, then we create a new randomized set. Insert. Well, there's actually two inputs here, insert, and it goes with the array down here. So randomized set, empty array, insert 1. So it does insert 1 and it returns true. Remove 2. That's not going to work. So it returns false. 2 does not exist. Insert 2. The insert works and 2 gets inserted. Get random. That could return 1 or it could return 2. Next, remove 1. Remove 1, removes 1, returns true. So the set now just contains the number 2. Insert 2. That's not going to work. Insert 2. 2 is already in the set, returns false. And get random. There's only one item in there, so that is going to return true. Okay, well, Java has a set interface. It has a hash set class that implements insert and remove in O1. It doesn't have a get random though, so the idea of just using a hash set is out. Let's see what topics are covered here. Topics, they kind of gave it away here. Array, hash table. Right. So we can't use a hash set, but we can use a hash. We can use a hash. Well, not a hash table, but we can use a hash map. And an array, we can't really use an array either because we can't resize it, but we can use an array list. So let's go with that. All right, well, I mean, there's nothing really to sketch out here. So I'm just going to start typing here. Class, public, randomized set. All right, so to create the randomized set, we're going to need, oh, yeah, that can't be in there, though. We got to put it, well, let's start by putting it up here. List, we're using integers here. We'll call it array, ARR, and that equals a new array list. In Java, if we don't put integer here after array list, it defaults to whatever we put here. So we've got an array list of integers. All right. We need the array list, and then we need the hash map. So let's do that. Map integer and integer. I'll say a little bit more about the hash map in a second. We'll call it map, and that is a new hash map. The hash map is, well, what we're going to have in the hash map, the array values will be keys in the hash map, because that lets us do an O1 lookup for things like insert, remove. We can do an O1 lookup and see if that value is in the array list. So the array values are keys, and the array indexes are values. Because we have a resizable array, we can do an insert in O1 time complexity, and we don't have to do anything special to make that happen. So the constructor is really not, we don't have to do anything there. Insert. All right. So to do an insert, we have to check if val is already present by doing a hash map lookup. If it's not present, we're going to insert it at the end of the array list and add it to the hash table. All right. If not map contains key x, no, let's make it val. If it does not contain it, then int index equals ARR dot size. We're going to put it at the end. By putting it at the end, I mean, again, it's resizable. If we put it in the middle, then it's not O1 anymore, because we have to shift everything down. So we're just going to put it at the end. So the index will equal array dot size. We will do an add on value, and then do a put on val index. Okay, and return true. If the map does contain the value already, then we can't insert it again. So in that case, we'll just return false. Okay. Remove. Well, remove is the hardest, so let's come back to that. GetRandom Okay, random, rand equals new, random, int, random index, radon index, no, random index equals rand, rand dot next int, and we want to cap that at array dot size. Now what are we supposed to do? Are we supposed to return, we return the random integer, right? GetRandom returns a random element. Okay, in that case, we'll return arr.get random index. Okay. Remove is the hardest. Why is that? Because we can do an O1 lookup to see if val is in the array list, but if it's in the middle and we have to remove it from the middle, then it's not O1 anymore, because we have to shift all the elements to the right of whatever element we removed to close up the space, and that takes longer if you've got a bigger array. Now it's O of n. So in order to remove it, we're going to check and see if it's there. If it is there, we'll get its index from the hash map, and then we're going to swap it. We're going to swap it with the last element in the array, okay? And we're going to swap it because we can take the last element off the array list in O1 and then update the index in the hash map. So let's try that. What do we have up here? Okay, well, we'll just, yeah, we can just type it. All right, if map dot contains key val, if it's in there, then int index equals map dot get val. All right, so now we've got the index of the val, the index in the array list. Map dot remove val. It's gone. Okay. If index is not equal to array dot size minus 1, meaning if the index is not already the last element of the array, then we're going to have to swap it. Okay, so we'll say int last equals, I'll just copy this, last equals array size minus 1. Java has a swap method in the collections swap. We're going to swap, that's our collection, the array, and we're going to swap index and last. Okay. If last is not equal to index, then map dot put array dot get index and index. All right, what are we doing with the if statement? Well, the collections dot swap is assuming that the value we're removing is not already the last element of the list. We are swapping it with the last element of the list. So we're swapping the last element of the list into the middle of the array list somewhere. So we have to change its index in the hash map. So we say map put the value and the index. And the way put works is it'll work whether or not the value is already in the map. If the first parameter is not in the map, then it'll add it to the map. If it is in the map, it'll update it. So that'll work. That'll work to do an update. All right. And finally, we have to, after the if statement, right? Now, after that, after this, it's got to be inside the if statement. We've got to say array dot remove arr dot size -1. Okay, remove the last element, which we can do in O of 1. I almost forgot this is Boolean, so if it is in there, everything works, then return true. Okay, if it doesn't work, return false. Let's run this. All right, so the basic cases are accepted, and we'll do the submit. Okay, that's accepted. Somebody's 48.24. Okay, it's all right. So that's the that's the O1 randomized set. Feel free to like, subscribe, and I'll see you next time.